Stoichiometry calculations with particles and volume. The number of particles, which we've defined earlier as atoms, molecules, or formula units, is directly proportional to the number of moles. Therefore, this equation here, this balanced equation, 2 hydrogen plus oxygen yields 2H2O. And let's look at the pictures here. We have 2 H2s. Each one of the green guys is a hydrogen atom. 2 oxygens, and then we have 2 water molecules here. That can be read as 2 molecules of H2, 1, 2, plus 1 molecule of oxygen, see the one there, yields 2 molecules of water. Now note, while we can talk about moles as non-whole numbers, particles must be whole numbers. You can't have 6.1 atoms, molecules, or formula units. It has to be an integer. Stoichiometry calculations with volumes. When you have a given temperature and pressure, the space a sample of gas takes up, its volume, is proportional to the number of moles of gas molecules present. Therefore, this equation here, 2H2 in the gaseous form plus O2 in the gaseous form yields 2 H2Os in the gaseous form, that's water vapor, and it's represented with these balloons here. Okay? You can read that as 2 liters of hydrogen plus 1 liter of oxygen yields 2 liters of water. Note, the volume of a material is only proportional to the number of moles when the substance is in the gaseous phase, and all 3 of these are in the gaseous phase. Now let's make it a little trickier. We're going to deal with particles and volumes. It's common to be asked to report a value in a unit other than the one given. So here's an example that we're going to go through. Given the following reaction, how many liters of nitrogen gas would be needed to produce 3 moles of ammonia? Notice how we have different units here. We're going from liters to moles, and we have nitrogen plus hydrogen yields ammonia. Given the following reaction, nitrogen plus hydrogen yields ammonia, how many liters of nitrogen gas would be needed at standard temperature and pressure to produce 3 moles of ammonia? So basically what we have here, we have moles of ammonia, which we have to convert to moles of nitrogen, and then convert that to liters of nitrogen. So we have 3 moles of ammonia. That's given here. Okay. Now let's look at our balanced equation. We have 1 mole of nitrogen, see there's a 1 in front here, for every 2 moles of ammonia. So that's this term. Then we know that 1 mole of a gas is 22.4 liters. So we multiply all these together and let's see what cancels out. Well, moles of ammonia goes away. We have this mole canceling out with this mole, and what we're left is 3 times 1/2 times 22.4, and we have nitrogen left over and we have liters left over. So our answer will be 33.6 liters of nitrogen. Example number 2. How many moles of chlorine gas would be needed to produce 3.0 times 10 to the 24th formula units of sodium chloride given the following reaction? This is a balanced chemical equation. We have sodium plus chlorine gives us salt. What we're converting here are formula units of sodium chloride to molecules of chlorine gas, and then how many moles of that? So here's our formula units of sodium chloride. That's what we're given. Now we know that 1 molecule of chlorine, and I'll put the 1 here again, equals 2 formula units of sodium chloride. So that's this term here. Then once we have the mole, we have 1 mole of chlorine is 6.02 times 10 to the 23rd molecules. So we multiply these together, and the formula units of salt go out like this. The molecules go out like this. And we're left with moles, and let me change color on this just for fun. We're left with the moles of chlorine, okay? So 2.5 moles of chlorine gas.